Now listen carefully and answer questions 11 to 14.
Good morning, everyone. My name's Janet Parker, and I'm the Human Resources Manager. We're very happy to welcome you to your new apprenticeship. I hope that the next 6 months will be a positive and enjoyable experience for you. I'd like to start with some general advice about being an apprentice. Most of you have very little or no experience of working for a big organisation, and the first week or so may be quite challenging. There will be a lot of new information to take in, but don't worry too much about trying to remember everything. The important thing is to check with someone if you're not sure what to do. You'll find your supervisor is very approachable and won't mind explaining things or helping you out. You're here to learn, so make the most of that opportunity. You'll be spending time in different departments during your first week, so make an effort to talk to as many people as possible about their work. You'll make some new friends and find out lots of useful information. As well as having a supervisor, you'll each be assigned a mentor. This person will be someone who's recently completed an apprenticeship, and you'll meet with them on a weekly basis. Their role is to provide help and support throughout your apprenticeship. Of course, this doesn't mean they'll actually do any of your work for you. Instead, they'll be asking you about what goals you've achieved so far, as well as helping you to identify any areas for improvement. You can also discuss your more long-term ambitions with them as well.
Before you
Now listen carefully and answer questions 21 to 25.
Hello, Professor. I'm John Wishart. I'm working on my entry for the Global Design Competition. My tutor said you might be able to help me with it.
Ah, yes, I got a copy of your drawings. Come in and tell me about it. What sort of competition is it?
Well, it's an international design competition, and we have to come up with a new design for a typical domestic kitchen appliance.
I see. And are there any special conditions? Does it have to save energy, for example?
Actually, that was the focus in last year's competition. This year's different. We have to adopt an innovative approach to existing technology, using it in a way that hasn't been thought of before.
I see. That sounds tricky. And what kitchen appliance have you chosen?
Well, I decided to choose the dishwasher.
Interesting. What made you choose that?
Well, they're an everyday kitchen appliance in most Australian houses, but they're all pretty boring and almost identical to each other. I think some people will be prepared to pay a little extra for something that looks different.
It's a nice idea. I see you've called your design the rock pool. Why is that?
Basically because it looks like the rock pools you find on a beach. The top is made of glass so that you can look down into it.
And there's a stone at the bottom. Is that just for decoration?
Actually, it does have a function. Instead of pushing a button, you turn the stone.
So it's really just a novel way of starting the dishwasher.
That's right.
It's a really nice design, but what makes it innovative?
Well, I decided to make a dishwasher that uses carbon dioxide.
In place of water and detergent? How will you manage that?
The idea is to pressurise the carbon dioxide so that it becomes a liquid. The fluid is then released into the dishwasher where it cleans the dishes all by itself.
Sounds like a brilliant idea. Your system will totally do away with the need for strong detergents. So what happens once the dishes are clean?
Well, to allow them to dry, the liquid carbon dioxide and the waste materials all go to an area called the holding chamber. That's where the liquid is depressurised and so it reverts to a gas. Then the oil and grease are separated out and sent to the waste system.
It sounds like you've thought it all out very thoroughly. So what happens to the carbon dioxide once the process is complete? Not wasted, I hope.
Actually, that's where the real savings are made. The carbon dioxide is sent back to the cylinder and can be used again and again.
What a terrific idea. Do you think it will ever be built?
Probably not, but that's okay.
Well, I'm sure a lot of positive things will come out of your design.
Now listen carefully and answer questions 11 to 16.
Good morning, everyone. My name's Joy Parkins and I'm the restaurant manager. And I understand that none of you have had any previous experience as kitchen assistants. Well, you might be feeling a bit nervous now, but most of our kitchen assistants say they enjoy the work. OK, they might get shouted at sometimes, but it's nothing personal. And they're pleased that they have so many different things to do, which means they never get bored. And I'll tell you straight away that if you do well, we might think about moving you up and giving you some more responsibility. Right, well, you've all shown up on time, which is an excellent start. Now, I'm glad to see none of you have unsuitable footwear, so that's good. You need to be careful as the floors can get very wet and slippery. Those of you with long hair have got it well out of the way, but some of you'll need to remove your rings and bracelets. Just put them somewhere safer today, and remember to leave them at home tomorrow, as they can be a safety hazard. Now, it's going to be a busy day for you all today. We don't have any tables free for this evening and only a few for lunch. Fortunately, we've got our head chef back. He was away on holiday all last week, which meant the other chefs had extra work. Now, I'll tell you a bit more about the job in a minute, but first some general regulations. For all of you, whatever your age, there's some equipment you mustn't use until you've been properly trained. Like the waste disposal system, for example, for health and safety reasons. Then I think there are 2 of you here who are under 18. That's Emma and Jake, isn't it? Right, so for you 2, the meat slicer is out of bounds, and of course none of you are allowed to use the electric mixer until you've been shown how it works. Now, you may have heard that this can be a stressful job, and I have to say that can be true. You'll be working an 8-hour day for the first week, though you'll have the chance to do overtime after that as well if you want to. But however long the hours are, you'll get a break in the middle. What you will find is that you're on your feet all day long, lifting and carrying, so if you're not fit now, you soon will be. You'll find you don't have much chance to take it easy. When someone tells you to do something, you need to do it straight away. But at least we do have a very efficient air conditioning system compared with some kitchens.
Now listen carefully and answer questions 21 to 27.
OK, Greg, so I finally managed to read the article you mentioned, the one about the study on gender in physics.
About the study of college students done by Akira Miyake and his team. Yeah, I was interested that the researchers were actually a mix of psychologists and physicists. That's an unusual combination.
Yeah. I got a little confused at first about which students the study was based on. They weren't actually majoring in physics. They were majoring in what's known as the STEM disciplines. That's science, technology, engineering and
math. Yes, but they were all doing physics courses as part of their studies.
That's correct. So, as I understood it, Miyake and co. started from the fact that women are underrepresented in introductory physics courses at college, and also that, on average, the women who do enroll on these courses perform more poorly than the men. No one really knows why this is the case.
Yeah, but what the researchers wanted to find out was basically what they could do about the relatively low level of the women's results. But in order to find a solution, they needed to find out more about the nature of the problem.
Right. Now, let's see if I can remember. It was that in the physics class, the female students thought the male students all assumed that women weren't any good at physics. Was that it? And they thought that the men expected them to get poor results in their tests.
That's what the women thought, and that made them nervous, so they did get poor results. But actually, they were wrong. No one was making any assumptions about the female students at all.
Anyway, what Miyake's team did was quite simple, getting the students to do some writing before they went into the physics class. What did they call it?
Values affirmation. They had to write an essay focusing on things that were significant to them, not particularly to do with the subject they were studying, but more general things like music or people who mattered to them.
Right. So the idea of doing the writing is that this gets the students thinking in a positive way.
And putting these thoughts into words can relax them and help them overcome the psychological factors that lead to poor performance. Yeah. But what the researchers in the study hadn't expected was that this one activity raised the women's physics grades from the C to the B range.
A huge change. Pity it wasn't to an A, but still. No, but it does suggest that the women were seriously underperforming beforehand in comparison with the men.
Yes. Mind you, Miyake's article left out a lot of details, like did the students do the writing just once or several times? And had they been told why they were doing the writing? That might have affected the results.
You mean if they know the researchers thought it might help them to improve, then they just try to fulfill that expectation?
Exactly.
Before you hear the rest of the discussion, you have some time to look at questions 28 to 30. Now listen and answer questions 28 to 30.
So anyway, I thought for our project we could do a similar study, but investigate whether it really was the writing activity that had that result.
OK, so we could ask them to do a writing task about something completely different, something more factual, like a general knowledge topic.
Maybe. Or we could have half the students doing a writing task and half doing something else, like an oral task.
Or even half do the same writing task as in the original research and half do a factual writing task. Then we'd see if it really is the topic that made the difference or something else.
That's it. Good. So, at our meeting with the supervisor on Monday, we can tell him we've decided on our project. We should have our aims ready by then. I suppose we need to read the original study. The article's just a summary.
And there was another article I read by Smolinski. It was about her research on how women and men perform in mixed teams in class, compared with single-sex teams and on their own.
Let me guess, the women were better at teamwork.
That's what I expected. But actually, the men and the women got the same results, whether they were working in teams or on their own. But I guess it's not that relevant to us.
What worries me, anyway, is how we're going to get everything done in the time.
We'll be okay now we know what we're doing. Though I'm not clear how we assess whether the students in our experiment actually make any progress or not.
No, we may need some advice on that. The main thing's to make sure we have the right size sample, not too big or too small.
That shouldn't be difficult. Right, what do we need to do next? We could have a look at the timetable for the science classes. Or perhaps we should just make an appointment to see one of the science professors. That'd be better.
Great. And we could even get to observe one of the classes.
What for?
Well, OK, maybe let's just go with your idea. Right, well, I think that's everything for now.